a reflection of light. When you see into a mirror, you can see your image in mirror. Water. In water also you can see the image. This is because of a reflection property of the light. When light falls on a polished or smooth surface, it bounces back from the surface in a well-defined direction. This phenomenon is called a regular reflection. And when light falls on an uneven or unpolished surface, it gets scattered in all directions. This is called irregular or diffused reflection. In case of a plane mirror or a polished surface, we observe a regular reflection. Or in case of crushed ice, we observe irregular reflection. First, we discuss about the terms related to reflection. In general, the reflection of light is represented as we are seeing in the figure. This prime, this is reflecting surface. When light incident on this surface, if this surface cannot transmit the light, it will be reflected in this direction. Now this is incident ray and this is reflected ray. At point where a light incident on the surface, a normal is drawn, and with respect to this normal, the direction of incident ray and reflected ray is defined. In this case, this is the normal, this is incident ray. The angle between incident ray and normal is called angle of incidence. The angle between a reflected ray and normal is called angle of reflection. The angle between a reflecting surface and incident ray, this is 90 minus I. Similarly, the angle between a reflected ray and reflecting surface is 90 minus R. This is called glancing angle of incidence and this is called glancing angle of reflection. The laws related to the reflection are the incident ray, the normal at the point of incidence and the reflected ray all lie in the same plane. This is the first law. The second one is the angle of reflection is equal to the angle of incidence, that is angle I equal to angle R. These two are laws of reflection. We take this small experiment to verify laws of reflection. On a drawing board, place a mirror prime. Place two pins P and Q in front of the mirror as are seeing in the figure. The images of these two pins will form inside the mirror. By observing these two images from this direction, you arrange again P prime and Q prime so that all these four pins are in the same line. If you join PQ and extend the line up to mirror, now this is the incident ray. Similarly, connect P prime, Q prime and extend up to the mirror. This is the reflected ray. We can assume that the ray is coming from this direction and reflects in this direction. This is the incident ray and this is the reflected ray. Now replace this mirror, drawing a line. This is reflecting surface and this is silver surface. At point of incidence, draw the normal. Now you measure the angle between normal and incident ray, that is angle of incidence, and measure the angle between normal and reflected ray, that is angle of reflection. And you can find that angle of incidence is equivalent to angle of reflection. This is second law of reflection. The first law of reflection is incident ray, normal at the point of incidence and the reflected ray all lies in the same plane. And the second one is the angle of incidence is equal to the angle of reflection. These two laws can be verified using this experiment. Now we take some different cases related to reflection. Now this is the normal. If ray incidents along the normal, then what happens? In this case, the angle of incidence is 0. The angle of reflection, this is also 0. If the light ray incidents on the surface along the normal, then it reflects back along the normal as we are seeing in the figure. Suppose if the angle of incidence is 60 degrees, then yes, the angle of reflection is 60 degrees. What about this angle? Now this is 90 and this angle is 30 degrees. While doing the problems related to reflection, the important thing is the angle of incidence is equivalent to angle of reflection. Representing the different phenomena related to light, that is reflection, refraction, this is called ray diagrams.